Hey Hayden, this is Miss Tracy. Let's go through lesson 117, 118. So now you have struggles with word problems. The thing to remember with word problems is that there are key words that you've got to pay attention to. So these variation problems, the key word to look for is inversely or directly. So here we've got inversely right there. So that tells me if it's inverse, it's going to be division. So inverse is equal to the division, and directly is equal to multiplication. Those are the things that you've got to remember when setting up the problem. So because it says inverse, we're going to do it division. So you've got the first thing, A, is equal to K over B. So let's find out what the first thing is. This is the division format. So it says the weight of a body. So the first thing we're looking at is weight. So W is equal to K over what? What is our second thing, our B? It's the weight of a body on or above the surface of the earth. None of this, like all of your prepositional phrases, on or above the surface of the earth, we don't care about those. Those can go away. We're carried about the weight that varies inversely with what? The square of the distance. So the square of the distance. So it's distance square. Okay? Weight varies inversely with the square of the distance. All right? We don't care about the rest of it. We don't need to know from what to what. That's unnecessary. We need to know the subject and its direct object. That's what we're looking for. So the subject and the direct object. So the weight varies inversely, so that tells us the how, that tells us the formula, so that tells us division because it's inversely, okay, with the square of the distance. So the subject with the direct object. That's our formula. The next sentence is going to tell us what values to put in to find this constant, the scale factor that we're using. Okay, so it says if a body weighs, so there's the weight. The weight is 50,000. So we put that in here. 50,000, where W is, equals K over what? Distance of 6,000. So that's 6,000. And we're going to square that. So this is weight and distance squared. We used this formula and we're going to put in our values. We're going to substitute our values. And we're going to use that to find the constant K. Then we're going to take that constant K to apply that to a second scenario that will give us the weight given a certain distance. The problem with this problem is that we've got a whole lot of stinking zeros, right? So we need to kind of simplify it so we don't have to deal with all of those place values. The way we do that is scientific notation. So when you have a lot of zeros here, you want to use scientific notation to make it simpler, because that's what it does. It's easier to do the math because you don't have as many place values to multiply. So we're going to reduce this into scientific notation. We know that this number needs to be 5 times 10, and that exponent is going to be 1, 2, 3, 4. So 5 times 10 to the 4th power is 50,000. Is equal to K over, now this is going to be 6 times 10, and this is 1, 2, 3, so to the 3rd power, squared. Now our first step is to get rid of this exponent here, because that's what PEMDAS tells us. PEMDAS tells us parenthesis, which we undid this, right? So we want to leave that way. So we're not going to do what's in the parenthesis. We're going to skip it and do the exponent. So the exponent on the parenthesis is what we're doing first. So when you have a power raised to a power, we multiply that, right? And we also know we multiply this. essentially, when this is squared, all we really have is this. 6 times 10 to the third. So that's the same thing as this squared. It's exactly the same thing. So I'm going to rewrite it that way. 5 times 10 to the fourth power is equal to k over, let's do the multiplication. 6 times 6 is 36 times 10, and 3 plus 3 is 6. Now I know that I can't have two places. I need to have one place. So I'm going to move the decimal one place and put it here. And I'm going to add 1 here. 6 plus 1 would be 7. So 3.6 times 10 to the 7. This is my denominator now, and it's in scientific notation. So what I'm going to do is I'm going to multiply both sides by 3.6 times 10 to the 7 in order to get rid of the denominator. I'll do that over here too. 3.6 times 10 to the 7. This cancels this. So k is equal to 3.6 times 5, which is going to be, it'll tell us on the calculator, 3.6 times 5 is 18. So 18 times 10, and 7 plus 4 is 11. But we know we only want one place, so we move it again. 1.8 times 10, we're going to add one space. So then this becomes 12. This is your answer. 1.8 times 10 to the 12th position. Or the 12th power, not position. This is our constant. This is what we're going to use. We're going to use this to solve the second scenario. And the second scenario is this. How much would it weigh? So we're looking for weight. We don't know what the weight is. We do know what k is now. We know k is 1.8 times 10 to the 12th power. We know that. That's a given for us. And our distance is 25,000 miles. Well, I'm going to go ahead and take 25,000 and put it in scientific notation. That'll be 2.5 times 10, and that's 1, 2, 3, 4 to the fourth power. Since it's squared, I'm just going to write it again just because that's easier than dealing with, the exponent. Now I'm going to go ahead and do this multiplication. So the weight is equal to 1.8 times 10 to the 12th power. 2.5 times 2.5. Pull up my calculator, figure that out. 2.5 times 2.5. 6.25, all right? 6.25 times 10, and I add these two together and I get 8. Now I can divide these. So if I divide these, I have 1.8 divided by 6.25. That's 0.288. So weight is equal to 0.288 times 10, and if I take this to the top, that subtracts, so that'll be 4. But we know we need to have something in the ones place, so I'm going to rewrite it and move this up, 2.88 times 10. Because I moved my decimal back a space, I have to subtract 1, that makes that 3. This is your answer. Okay? So remember what we did. We have to remember to look for our keywords, inverse or directly. Inverse means division, directly means multiplication. Here's the way that I remember it, and the way that makes sense for me. The D's can't go together. Directly cannot be division. The D's are going to be for separate things. And then I also remember that multiplication has a bunch of I's in it, right? So we can't put I's together. Inverse and a bunch of I's in multiplication, that has to be separate. All right? You can't put the D's together. They're in opposite locations. So inverse is division, and directly has to be multiplication because it's the other one. You just can't put them in the same row. That helps me keep them straight. All right, so let's look at the next problem. All right, so here we have the distance required. So there's our keyword. Distance is one of the things we're going to be talking about. So let's go ahead and underline that. The distance required for an automobile to stop is, so that's our equal sign. So distance equals, D equals, directly. So D directly is multiplication. So this is going to be multiplying. We're going to multiply because it says directly to the square of its velocity. So we're going to multiply K times the square of its velocity. So velocity squared. This is the formula we're going to use because it's direct, it's multiplication. Remember? Inversely equals, let me move this back, equals, I'm too close to the top, K over whatever the second thing is, right? And directly is equal to K times whatever the second thing is, right? So division, multiplication. So here we have multiplication. So now we can start dropping in our numbers and getting this set up. If a car can stop in 1,800 meters, meters is distance. So 1,800 meters is equal to, and actually you don't even have to write the unit of measure on these, K times what? From a velocity of 30 kilometers an hour. So that's 30 and it's squared, the velocity squared. So 1,800 is equal to K. 30 times 30 is 900. So it's K times 900, right? So these are two factors that equal 1,800. So to find out what K is, we divide by the factor that we know, and that's 900. 1,800 divided by 900 is 2. So the constant K is 2. So now we read the second scenario. What will be the required distance? So what is the distance? So D is our variable. And our constant K, that's 2 times 28 kilometers an hour. That's our velocity. Velocity is just another word for speed. So our distance is equal to 2 times, now we're going to find out what 28 squared is. So 28 times 28 is 784. And now we just need to multiply that by 2 to find out what the distance is, times 2. 1,568. And that's going to be in meters. Remember, that's meters is our unit of measure. So 1,568 meters. That would be your final answer. All right, you've got to be able to pay attention. Sometimes you've got to draw a picture, right? I've talked about that before. Sometimes drawing a picture is necessary to understand what's going on. Sometimes you can't just translate it straight into a formula. This keyword will help you do that, but sometimes you might want to draw a little picture here of a car. This is a horrible car, I know. And you want him to stop. That's a terrible little stop sign. And it's all about the distance from when he is speeding to when he stops. So the distance here, that's what we're looking for. This is my little picture that tells me what I'm trying to do. So I can wrap my head around the question. Okay. And distance is equal to the velocity squared. What is that number times velocity squared that gives it to me? This helps me draw this formula out. So think about things like that. If you can't quite wrap your head around how to do the problem, try sketching it out first. And what that does for you, it helps you to think more about what's actually going on. If you can sketch it out, then you'll understand, you'll grasp what you need to do to solve it. It will help you see it better. So get some scratch paper, draw it out the best of your ability. Even if you just have to use stick figures, it's okay. It's whatever is necessary for you to understand and solve the problem. That's what matters. Figure out what you need. All right? Let's move on to the next one. All right, so here's another one. This one says the distance, so that's what we're looking for. I'm just going to use my highlighter here. The distance varies directly. So that's going to be multiplication to the square of the time. So I've got distance varies directly with the square of the time. So that directly means multiplication. This is my formula. I'm going to drop in the information that I have. If it falls 256 feet, that is a distance. In 4 seconds, that is a time. So 256 is equal to k times 4 squared. That's my formula to solve for k, my constant. So I solve for this first. 4 times 4 is 16. 256 is equal to k times 16. Divide both sides by 16. Then that will tell us what k is. So I pull out my calculator. And let's see. 256 divided by 16 is 16. How about that? So 16 is the value of k. All right. Now I know what to drop in for k in. I'm going to just rewrite this formula, but I'm going to put the new information in. How far? So it's asking me for the distance. We don't know what the distance is. How far in 13 seconds? So distance is the thing we don't know. We know that k is 16, and 13 seconds is the new time. So I'm going to do this calculation to give me the distance. So the distance is equal to 16 times 13 squared. So 13 times 13 is 169. So 16 times 169 is 2,704. So 2,704, and the unit of measure is feet. That's your answer. 2,704 feet is how far it will fall in 13 seconds, given these conditions. Okay? All right, so like I said, use the keywords to set up the equation. Sketch a picture. It's like sketching a picture, but you can still sketch a picture if you need to. And then drop in the information that matches, find out what you need for the second time, and drop in the other. Let's look at another one. All right, the number of red marbles. So we've got red marbles, right? Varied inversely. So inversely means division. As the square of the blue marbles. So red varied inversely, so that means division, as the square of the blue marbles. I want you to take that formula, drop in the information, solve this one for yourself. I want you to take what we have done and apply it here. Okay, see if you can solve this one on your own. All right, now we're in lesson 118. So we have to complete the square in order to solve these, in order to solve for x. But in order to complete the square, we've got to get the x's on one side and everything without an x on the right side. So I'm going to add 7 to both sides, 7x, and I'm going to add 9 to both sides. This cancels, this cancels. So I have x squared plus 7x is equal to 9. And you always want to leave a little space here so you can write the square part that you need to complete the equation. Now, the reason we can do this, we remember, is because whatever you do to one side, you have to do to the other. So what we're going to do is we're going to find a value that we can add to both sides that will let us factor this as a square. That's the point. So I'm going to take this number. The way we do that mathematically is we take the middle number with the x term, we divide that by 2, and then we square it. And that's going to be 49 over 4. This is the number that we add to both sides. Okay, so plus 49 over 2 plus 49 over, 4 over 4. So we don't really do anything with this. We just kind of put it here on the left. But on the right, we have to actually put these together. So I'm going to turn this into a fraction that equals 9 with a denominator of 4. And I do that by multiplying 9 times 4 is 36. So 36, and I wrote it wrong. 36 over 4, still a value of 9. So now that I've done that, I can factor this as a square. So when you get to that part, you just say x, and then whatever this term is, this is the middle, or the, I keep moving that, or the x term divided by 2. So this is the term that we use to factor. So if it's positive, then you say plus. If it's negative, you say minus. And then we square that. That's all we do. Now we go ahead and add these two together. So this would be 3 plus 4 is 7, and then 6 plus 9 is 15. 70 plus 15 is 85 over 4. Now, to get rid of this square, because we have x by itself, so to get rid of the square, we're going to find the square root of everything. And this would cancel, so we can take away the parentheses. It just becomes x plus 7 over 2, and that would be plus or minus, because now we have a solution here. We can't find the square root of 85, but the square root of 4 is 2. Now we can subtract this from both sides and rewrite it. X is equal to negative 7 over 2 plus or minus square root of 85 over 2. Now, I'm not sure how we put that in. Let me see. Let's go back to this. Yeah, I think it's just negative fraction 7 over 2 plus or minus, and then you have a fraction, and then you have the square root of 85 over 2. And I believe it takes it just like that. Yes, that's correct. All right, so let's look at the next one. So here we have x squared minus 5x is equal to 6. All right, so x squared minus 5x is equal to 6. Now I moved that over because this already has all of our x's on this side, right? X squared minus 5x is equal to 6. So I just made room for that term that we're going to add when we do this calculation. So this is a negative 5. This is our middle x term. So I'm going to come over here to the right, my little scratch notes, and I'm going to divide that by 2. This is the number that we're going to put in as our factor. We don't even have to think about it, but we do have to square it to find what number we add to both sides. So negative 5 times negative 5 is 25, and 2 times 2 is 4. This is what we add. Plus 25 over 4 plus 25 over 4. So in order to make this the same denominator, I'm going to multiply this by 4. So that's going to be 6 times 4 is 24. Where's my pen? 24 over 4. So now I can factor this and combine this. So all I have to do to factor this is I'm going to say x, and this is negative 5 over 2. So minus 5 over 2 squared is equal to 49 over 4. In order to resolve this, I'm going to unsquare it and unsquare it. So then this is going to cancel that. So I have x minus 5 over 2 is equal to 7 over 2 with a plus or minus sign in front of it, because we have to account for the fact that these could be negative as well as positive. So now I can add this to both sides. Plus 5 over 2 plus 5 over 2. So x is equal to 5 over 2, positive 5 over 2, plus 7 over 2, or 5 over 2 minus 7 over 2. Could be either one of these. We have to allow for the plus or minus to kick in. So x is equal to 5 plus 7 is 12, divided by 2 would be 6. Or 5 minus 7, that's a negative 2. Negative 2 divided by 2 is negative 1. So these are our two possible answers. Make sure you write that down. Remember, you see this little number right here? We put that right there. Okay? You don't even have to think about how to factor it. And this little number right here, that's what we added to both sides. We have to add that in order to factor this. That's just the way it works. All right, let's look at another one. So here's our next one. So we've got everything on this side, so we need to move this over. So then that would be x squared plus 2x, and I'm going to leave room, and I have a positive 4. You take this middle number right here, 2 over 2, which equals 1, and we square that, which still equals 1, right? So we're going to add 1 to both sides. We don't have to do anything to this. We don't have to change it because they're both whole numbers. So we can go ahead and factor. This is a positive 1, so x plus 1 squared is equal to 5. Unsquare everything. Unsquare everything. Cancel. X plus 1 is equal to plus or minus the square root of 5. So when I subtract 1 from both sides, x is equal to negative 1 plus or minus the square root of 5. That's your solution. All right, let's see if there's one more. All right, so let's practice on this one. Make sure you write the problem down. Follow along. So What is our first step? I want you to write it down on your paper. What is the first step? Pause the video if you need to. All right, assuming you have already written the first step, you should have x squared plus 3x is equal to positive 8. We got there because we added 8 to both sides. All right, I want you to pause the video and do the next step. All right, the next step would be plus, you have 9 over 2. I'm sorry, not 9 over 2. 3 over 2. I'm getting ahead of myself, squared, which would be 9 over 4. So plus 9 over 4 plus 9 over 4. All right, pause the video and write the next step. The next step is going to be turning this into a number with a denominator of 4. So that would be 32 over 4. Pause the video, do the next step. All right, the next step would be factoring. So x, this is 3 over 2, so plus 3 over 2, and that's squared. And then we add these together, so that would be 41 over 4. Pause the video, do the next step. The next step would be to find the square root, and this would cancel, right? Pause the video and write the next step. So the next step would be to write what's inside the parenthesis by itself, because we canceled the square. And then to unsquare this fraction, we will put the plus or minus symbol. And we know we can't unsquare 41, so we would leave the square root of 41 in the numerator. The square root of 4 is 2. That would go in the denominator. So pause the video and write the next step. So the next step would be subtracting 3 over 2 from both sides. So we'd have a negative 3 over 2 plus or minus the square root of 41 over 2. And that would actually be our final step. We can't go any further than that. So it's not a whole lot of steps. It's just understanding the process. That's all you're doing. You're understanding how to get from here to here. We just have our x terms on the left. We take this middle x, divide it by 2 and square it. So there's two 2's. You divide by 2 and then you square it. And you take that. That's the number that you add to both sides. The next step is to factor and actually combine both of those terms. Then you can unsquare both sides and solve for x. All right, I'm going to let you do the rest of the square problems yourself, completing the square. Follow the steps. If you followed along, you should know what they are. What you need to do when you write these problems down is you need to write down an explanation for each step. Write it down. Whenever I make little notes on the side, like take this number and divide it by 2 and then square it, and that goes up here. All of that needs to be in your notes. You need to understand the process because it's the same process every single time. Step 1, x is on one side and then the whole number on the other side, right? It's always going to have this format, whatever the x square is plus the x and a space and then the whole number. You're always going to do that. Then you're going to always divide. Let me rewrite that. Well, just divide the x term or the x number by 2. Then square that. Then add it to both sides. Right? That's where the hard stuff is. All of this is the hard bit. Once you get it organized and you get this number in here, the rest of it is fairly straightforward. Then you just do the operations that you know you need to do. Right? You factor on the left and you combine terms on the right. Then you solve for x. And then that's your answer. The only thing you have to really remember in the process is to use plus or minus, because this could be a negative times a negative or a positive times a positive. Those are your 5 steps. You're doing 5 steps every single time. Okay, so walk through the rest of these completing the square on your own. See if you can do those. If you're still struggling, let me know. All right, so here is our next problem that you may have trouble with. The rest of them were either completing the square or the inverse or the direct problems of varies inversely or varies directly. This is an exponential growth problem, and it uses a specific formula. So the amount in a certain amount of time is equal to the original amount times the rate in a certain amount of time, or to the certain amount of times power. So this is the formula that we're going to use for exponential growth. So let's read through. We're talking about the number of gremlins, okay? So at the beginning, there was just 1. So that is the original amount. The beginning, or initial, or the first, that's going to be your keywords to tell you the original amount. Just 1, okay? So the amount over time, we don't know what the time is yet, but it's 1. So let's see what our rate is. After day 1, there were 2. After 2 days, there were 4. In fact, every day the number of gremlins doubled. So our rate is times 2. Every day it multiplies what it has times 2 for the next day. So that's the rate. How many gremlins will there be after 9 days? So that's our number. So the amount in 9 days is equal to 1 times 2 to the 9th power. So all we need to do is go in here and find our calculator. And we're going to say 2 to the 9th power. I'm going to use my power key. That's the base 2. 9 is the exponent. 512. And since we know that 1 times 512 is 512, we can just skip this bit and go straight to the answer, 512, because, you know, the identity property of 1, it's always there. So that's how you're going to do that type of problem. Let's see if we have another like that. All right, so here was the next one. So this is just a conjugation problem. So we know we don't want a radical in the denominator. So in order to get rid of that, we have to multiply it times itself, because whenever we have a square root times itself, it becomes whatever is under the square root. It changes, right? So we're going to multiply this really straightforward times square root of 2 over square root of 2. And we know this is okay because anything over itself equals 1. And we know we can multiply any number times 1 and the value remains the same. So that's essentially what we're doing here. This is equal to 1. This times 1, it still remains this. It's just the form that changes. So let's look at what this is going to give us. I know already that square root of 2 times square root of 2 is equal to 2. Not a problem. Now I'm going to multiply 2 times the square root of 2 times the square root of 2. Well, I've got a square root of 2 times the square root of 2, so that's 2, right? So 2 times 2 would be 4. And now I have plus square root of 2 times square root of 2. Well, square root of 2 times square root of 2 is 2. 4 plus 2 equals 6 divided by 2, which equals 3. That would be the solution for that. All right. Okay, so this one is a graph, and it is asking us to sketch the graph of negative absolute value of x minus 3. Okay, so first of all, I see the absolute value, so that's going to be a V. You know, that's going to be the V shape, where it's the equal sloped line on both sides of the vertex, just like mirrored images of each other. So that is what that's going to be. And it's negative, so that means it's going to be an upside down V. And because we have this minus 3 outside of the bracket, that means it's going to be a shift on the y-axis, and it is exactly what it is. So when it's a shift on the y-axis, it reads exactly what we think it is, which is a negative 3, so down 3. So we come down 3, 1, 2, 3. This is where the vertex is on the y-axis, and it's going to be upside down, and there's no coefficient here, right? So that's going to be a 1. So that means it's a 1-to-1 slope, 1 over 1. So up 1, or down 1 over 1, down 1 over 1. So down 1 over 1, down 1 over 1, right? Down 1 over 1, down 1 over 1. So that's going to be our graph of this function. That's how you would answer that. That's how you would see it. All right, let's look at another one. Find the equation of the line that passes through point -2, 5 with a slope of -1/4. Okay, so they gave us a slope already. Let's go do that problem. So it's 2, 5 with a slope of -1/4. Let me clear this off. All right, so here's our point. Oh, I need my pen. Let's see, it was -2, 5. Yes, -2, 5 with a -1/4 slope. So -2, 5 is the point, and the slope is equal to -1/4. All right, so that's all we really need. So we rewrite it. Y is equal to -1/4 times x plus b, because we don't know what the y-intercept is yet. We're fixing to solve for that. So we put this point in here. Our y is 5. And we have -1/4. We have -2 is our point. So -2 over 1, because that's how you can write a whole number, plus b. So a negative times a negative is a positive. So 5 is equal to 2/4 plus b. I need to change this so I have a common denominator. So if I change this with a denominator of 4, then what I get is 5 times 4 is 20/4. That still equals 5. So if I subtract 2/4 from both sides, this cancels, and this becomes 18/4 is equal to b. Well, I can reduce this. I can divide 18 by 2 and get 9. So 9/2, because I can reduce this by dividing by 2. 9/2 is that's going to be the same. Oh, I'm sorry. You know what? I'm not going to reduce that fraction because this is my intercept point. It is what it is. I can't change it. So I have to take this and put it in exactly the way that it is. So y is equal to negative 1 over 4 x plus 18 over 4. I believe that's right. I don't think I can reduce that. Actually, no, I can. I can reduce that. I'm sorry. I'm sorry, we can reduce that. I'm not thinking clearly. It's a point, not a slope. I was thinking about slope for a rectangle. So 9 over 2 is what you'd want to put in there. I think it'll take it either way. We're going to find out. Y is equal to negative 1 over 4 x plus 9 over 2. Let's see if it takes it like that. Yeah, so that would be fine. Just put it in like that because you know it'll take it. So reduce the fraction when you can. All right, so let's solve this one. This is pretty straightforward. You just have to think it through. All right, x plus 2 minus 4 equals to 1. All right, so here we go. Square root, square root of x plus 2, okay, plus 2 minus 4 is equal to 1. Let me double check. Yes, all right, so that's correct. All right, so what we've got to do first is we've got to get this by itself. Remember when we completed the square, how we would square both sides? When we would factor, we'd have a square. We'd use this to undo it. Well, we're just going to square this to undo this. So we're going to add 4 to both sides to get rid of this because we want this by itself. So now we have this by itself. We have x plus 2 is equal to 5. So to get rid of this radical sign, we're going to square this whole thing. And we'll square both sides because whatever you do to one side, you have to do to the other side in order for it to remain equal, which is the whole point of math, is to seek truth. We want to keep this true. So now these two cancel. The square root and the square cancel each other. So x plus 2 is equal to 5 times 5, which is 25. If I subtract 2 from both sides, x is equal to 23. And that would be your solution. Now, always check your solution. So, 23 plus 2 minus 4 is equal to 1. All right? 23 plus 2 is 25 minus 4. 5 minus 4. Yep, that's equal to 1. So x is equal to 23. You always want to check your work and make sure that you can put it back in. That's going to tell you whether or not you understand. That's going to tell you what you're doing. So if you're not checking your work, that could be part of why you're not fully grasping what's going on, because the process of checking your work will show you your mistakes, will show you where you need to look. So do that. Always do that part. Don't be lazy. Follow through and check your answer. Okay, let's see if we have another. All right, so you have one that's letters that you're solving for a letter. And I feel like we've done those before, so I'm going to let you solve that one on your own. This one was fairly large and fairly mind-boggling. So I thought we would walk through this one just to make sure you've got it figured out. So the first thing I see is I've got brackets, I've got parentheses, I've got exponents. So we know we're supposed to solve PEMDAS, right? PEMDAS, that means parenthesis, exponent, multiplication in order from left to right, and addition and subtraction in order from left to right. And bracketed out, I can't really draw anything up there. Let's bracket it out like this, right? These first, this second, these together third, these together fourth. That's your order of operations. So we're going to do what's in the parenthesis, in the innermost parenthesis first. So the first thing I see in the innermost parenthesis that we have is an exponent. Exponent comes before addition and subtraction. So we address that. And when we address this one, we have 2 to the 0 power. That's a 1. So I'm going to look through and see if I have any more exponents. Okay, so I can calculate this one if I want to. I'm going to wait on it for just a second, though. I've got 2 to the 2nd power. Well, 2 times 2, that's going to be 4. I've got another 6 to the 0. Something to the 0 is always 1. And then I see here that I've got a radical. Well, it's not in a parenthesis with anything else, so I can wait on it. So let's just look at this again. So -3, I can't do anything with that yet because I still have parentheses in here that have things that need to be done. So I have -1 minus 3. Well, in this parenthesis now lives a -4 minus -5 plus 7. That's going to be a +2. So that lives in that parenthesis. Now I have another parenthesis. This is multiplication. So I'm going to start this one. -4 plus 3, that's a -1. Now I have my bracket. Minus, I have a bracket. I have a parenthesis. -1 minus 2, that's a -3. Plus, let's look at this first though. I have a -64 to the cube root. I'm just going to do that on my calculator. I know what it is. I know it's -4, but I'm just going to show you how you can do that. 64 negative. And you can, if you have a cube root button, you can press that, or you have a custom square root button or index button. You can click this, put your root, and hit equal, -4. So that's the number that goes here, -4, and then my bracket. That takes the place of this. Because it's a negative number, this becomes negative. Now I can just look and see what other operations I have. Okay, I have multiplication going on right here, so I need to do that before I do anything else. So -3, -4, I have 2 minus 1. So that's going to be a -2. Minus, I have -3 minus 4, that's a -7. All right, now I've got an operation within these brackets. So a negative and a negative, that becomes a +2. So I have -3, -4 plus 2 is a -2, and a negative times a negative is a +7. So -3 times -2 is a +6, plus 7 is equal to 13. That's your final answer. Work the steps. Work the order of operations. Take as many steps as you need to in order to solve it. It's okay. You don't need to hold it all in your head, right? You don't have to solve it all at once. You have paper. You have a pencil. Use them. Okay? Take your time and think it through. Math is more about logic. It assumes what we're doing now assumes you should know how to multiply, divide, add, and subtract. We're not working on those skills now. Now we're working on the combination of those skills in a logical order. Do you know how to use the logical order of those skills? That's what this problem is all about. Let's see if there's anything else. All right, last one. So we have to find the area of this figure, and the dimensions are in centimeters. So at first glance, you might be going, how am I supposed to know how tall this triangle is? Don't worry about trying to go all the way up here. Create a smaller triangle. Find the point here and come straight down. Now, we know how tall this is because we know how tall this is. This is a circle. The diameter goes all the way across. So it's level here. If this is 10, then this is 10. The whole thing is 20. So in order to find out what the base of this triangle is, we've got to subtract the width of this diameter from this total here. So if this is a radius of 5, then this is 5 and this is 5. 5 plus 5 is 10. So this is 10 and this is 10. Now we can solve. So we got the triangle, and we know the area of a triangle is going to be base times height divided by 2, right? So we've got 10 centimeters times 10 centimeters. That's 100 centimeters divided by 2. That's 50 centimeters square. That's the area of the triangle. Now we have a rectangle with a half of a circle taken out of it. So what we need to do is find the area of the rectangle here and then subtract the half circle. So let's do that. So this rectangle would be 10 by 10. It's actually a square because it is the same by the same. So we know that's length times width. So 10 centimeters times 10 centimeters is 100 centimeters square. So now we have the total area if this line were straight across. That would be 150 centimeters square. But we have to subtract this half circle. So we know that the area of a circle is pi r square, but it's a half of a circle that we're taking away. So we're going to divide it by 2 for half. So that's what we're doing here. So pi times 5 centimeters times 5 centimeters divided by 2. That's going to equal 5 times 5 is 25 pi, because we got to multiply by pi, divided by 2, and that's in centimeters squared. So we have our total area minus our half circle, which would be 150 minus 25 pi over 2, give it a space, and write cm square. So I'm going to go in here and make sure it'll take that. $150 minus fraction 25 pi over 2, close parenthesis, centimeters square. Let's see if it'll take that. Does not take that. I wonder why it's not taking that. Let's try taking, all right, we finished that. Let's do centimeter square by itself to the side. Still not taking it. Well, I know if, oh, I see why. That first parenthesis, it doesn't like it. Let's see if it'll take it now. If I go back in here, cm squared. Let's see if it'll take that. Yes. So what it was is whenever you do this back parenthesis, it automatically does a parenthesis. So there was an extra one right in the front that I didn't catch. So do your parenthesis, do your centimeter square, and then it takes it. So there you go. If you have any more questions, again, I didn't do all of the problems because I went over a fair amount of the ones that were alike. Do those on your own. If you have any questions about them, please let me know. Work your steps. Pay attention to the steps. They're the same every single time, just the numbers that change. You can do this. Give yourself room to make a mistake and redo it. It's okay if you don't get it right the first time. All right? And I'll see you in the next video. Bye for now. We're almost done. We're almost done. Stick with me. We've only got about 5 lessons. We're almost done. You've been a trooper. Keep up the good work. Bye for now.